All right, so let's look at some questions from the lesson 12 problem set. It's very similar to lesson 11. It's still kind of the same thing where we're doing a lot of the skills that we practiced before, but with fractions and with mixed numbers. So we're still dividing numbers to get rates and ratios. Just the numbers are a little bit harder. Last time there was 5 questions and I did the odds. This time there's 4 questions. I think I'll do the evens. So the first one, or well, the second one actually, says the area of a blackboard is 1 1/3 square yards. So I'll put a 2 down here. So there's a blackboard. We call them whiteboards now. Blackboards are old school. You would use chalk on them. And so the area of this thing, meaning like, you know, the whole 2-dimensional space that it covers, is 1 1/3. They say yards squared, or square yards. I like to say yards squared. It means the same thing. And then there's some poster, I guess maybe like next to it or something, that is 8/9 of a square yard. So not quite as big as this, maybe like this big. And that's 8/9 square yards or yards squared, same thing. Find the unit rate and explain in words what the unit rate means in the context of this problem. Is there more than one unit rate that could be calculated? There's always more than one you could calculate. If this is Blackboard, I'm just going to put a B for Blackboard, and this is the poster, P, you always have 2 options. You could always do B/P, which is like Blackboards per poster. And this is, and then you could do P/B, which is posters per Blackboard. And we're just thinking about like size ratios here, right? Like for every one poster, I'm gonna get more than one blackboard, right? Like I get more space on a blackboard than I do on a poster. So this ratio right here, Blackboard, I want to say Blackboards per poster, this should be greater than 1. Greater than 1, because I get more than one blackboard for every poster. But this one, on the other hand, posters per blackboard, if I'm looking at the ratio of how much poster I'm getting for every one blackboard, this one should wind up being less than 1. This is such a weird question. Like I'm having a hard time even like putting this one into words because it's such a strange thing, right? Like, you know, in fact, you know, maybe this one is, it's almost better if instead of using the word per here, let's think of it as a ratio of 2, right? Blackboard's 2 poster or poster 2 blackboard, right? Like thinking about which one's bigger and which one's smaller. The blackboard's bigger than the poster, so this ratio should turn out greater than 1, and the poster's smaller than the blackboard, so this ratio should turn out smaller than 1. This question's so weird and so silly about areas that it's like it's even hard for me to like talk through this one. All right, so let's calculate the blackboards to posters or blackboards per poster ratio, and that means I'm just going to take the blackboard area and divide it by the posters. So blackboards per poster, that's going to equal the 1 1/3, which I'll convert to 3 times 1 is 3 plus this 1, that's 4/3, divided by 8/9. But I do a keep change flip and I get 4/3 times 9/8, and that's 36 over 12. Oops, nope, sorry, I can't math. 36 over 24, I was thinking ahead. I was thinking about the fact that 12 is gonna go into the top and bottom of this fraction, and so I wind up with 3 halves, which, or if you prefer, that's 1 1/2. Okay, and so what this ratio tells us is that the blackboard is 1 1/2 times as big as the poster, right? Like if you think about adding half of the size of the poster, which would be an additional 4/9, you would get 12/9, which is same as 1 1/3. So that's why it's this is 1 1/2 times as big as this. And so let's do the other way. We get posters per Blackboard. Keeps wanting to say Blackbird. And so we're just going to do the opposite division. It's 8/9 divided by 4/3 this time. And we do a keep, change, flip. So change the multiplication, flip to 3/4, and I get the reverse fraction, right? We should have known that was going to happen. We should have known that I was going to get the flip of the previous answer, or the reciprocal is the actual math name. And so I don't even have to show that I'm going to divide by 12 both times. I know that if the last one was 3/2, this one's 2/3. So what that's saying is that you get 2/3 as much area on a poster as you do as the Blackboard. So it's weird to think about it, but this is essentially what we can explain in words from this. The Blackboard is 1.5 times as big as the poster, or equivalently, the next thing I say means the exact same thing as what I just wrote, but it's just going to be worded different, or the poster is 2/3 as big as the, I'm just going to write the board because I'm going to run out of space if I write Blackboard. All right, this marker's kind of dying. I'm going to grab a different one. That was a weird question. If that one didn't make much sense to you, do not feel bad because it barely made any sense to me. Let's see here. I used a lot of space on that, so I'm going to grab a piece of paper to do number 4 on. It says to make 5 dinner rolls, write a number 4 here, 1/3 of a cup of flour is used. That doesn't seem like a lot of flour for 5 rolls. All right. How much flour is needed to make 1 dinner roll? So I just want to know flour per 1 roll, or flour per roll. So that means I just do flour divided by rolls. That's 1/3 divided by 5, and I'll do it as 5/1. And so let me keep, change, flip. It's 1/3 times 1/5. That equals 1/15 of a cup. So you need 1/15 of a cup for each roll. I don't know how you ever measure that, but I don't think they make that size measuring cup. Okay, part B. How many cups of flour are needed to make 3 dozen dinner rolls? So there's a few different ways you could approach this problem, but I say, I already know how much you need to make one, right? 1 roll takes 1/15 of a cup. And if I want to make 3 dozen, well, hold on. Let me do a little side calculation over here. 3 dozen. A dozen equals 12. So 3 times 12 equals 36. So I want to know how much flour to make 36. Let me multiply this by 36/1. That is 36/15. That's a perfectly good answer, but maybe we could put it into a mixed number just to kind of see what it equals a little bit better. 15 goes into 30 2 whole times, and then I have 6 left over up top here, so it's 6/15 cups. All right, and then C. How many rolls can you make with 5 2/3 cups flour? Well, I know that every 1/15 cup gets me 1 roll. So if I do 5 2/3 divided by 1/15, then I'll figure out how many 1/15ths I have in here, and that's how many rolls I could make. So let me do some conversions here. I'm going to change 5 2/3 into an improper fraction. So 3 times 5 is 15, plus 2 is 17, so that's 17/3. And then I'm going to keep, change, flip. So instead of dividing by 1/15, I'm going to multiply by 15/1. All right, so now I got to do 15 times 17. Well, I know that 15 times 10 would be 150. And then let me handle the 7 here. 7 times this 10 would be 70. So I got a 150, I got a 70, and then 7 times the 5 would be 35. So I add all that together, it's 220 plus 35, that's 255. So I have 255, that's just on the top. I still have a 3 on the bottom. So to get my final answer, I need to do 255 divided by 3. I don't know whether or not 3 goes evenly into 255. Let's hear 5 plus 5 plus 2. I think it is going to go nicely in there. All right, I'm gonna be lazy. I'm gonna grab a calculator. Let's see. 255 divided by 3, 85. So you can make 85 rolls with 5 and 2/3 cups flour. 85 rolls. All right. So hopefully you can do the other two without my help. Usually it's just a matter of converting the mixed numbers into an improper fraction and then deciding to divide them in one way or the other. Either divide this number by that number or this number by that number. And you kind of just got to do your best based on what you understand from the problem. And if you wind up doing it backwards, it's not the biggest deal. It happens to the best of us. All right.